sequence. A sequence is an ordered list. There's a first term, a second term, third term, fourth term. Typically, you'd want to have an infinite number of terms. We can denote infinity with the 3 dots, the ellipses. As we look out into the sequence, we can pick out the nth term. That's any term that you like. If we pick the first, then the index I would equal 1. If we pick the second term, the index I equals 2. Index is equal to 3, index is equal to 4, and so on. Notice that in this particular case, the nth term is exactly equal the index. That is, a sub I is equal to I. That's for the particular case that we looked at. In general, we write down a sub n. A sub n is the general term, otherwise known as the nth term. Let's look at something familiar, the graph of sine. Sine is defined everywhere. All inputs are valid for sine. If we isolate out just the counting number inputs, 1, 2, 3, 4, 5, and so forth, then these black dots represent the graph of a sequence whose nth term is given by sine of n. It's very easy to come up with this graph of the sequence a sub n taken as sine of n. Let's look at how to do that. If we open up Desmos, we can see that here in the first entry slot, I have set f of x to be sine of x. That would produce the red graph of sine. In the second entry box, I have defined a list of 100 elements, which I have termed n. N is simply the first 100 counting numbers. In the third entry box, I tell Desmos that I would like to plot points. A point is an ordered pair. There's a first coordinate and a second coordinate. For the first coordinate, I'm just taking the first 100 counting numbers. 1, 2, 3, ... out to 100. Then I take as my y-coordinate the output. I simply evaluate sine at each of those counting numbers. That produces this plot. Give it a try. Here are some sequences for you to plot.